So thank you very much, first of all, for having me, for having Cipher Neutron on this panel. So I will jump right into the presentation. I will skip the disclaimer section. So what is Cipher Neutron? I mean, we are a privately held company in Toronto. So we are a Canadian company that focuses on low-cost green hydrogen solutions that include the AEM electrolyzers. We also have a patent pending innovative technology called reversible fuel cell. In this presentation today, we will talk more about the AEMs that we have, and then we will touch a little bit on the reversible fuel cells. So I think it's very important. I know it's a hydrogen conference, and there will be people who already know hydrogen will be listening to this presentation. But I think it's very important to understand what the real market is and what are the needs for hydrogen. Because whenever we discuss hydrogen, people usually think hydrogen cars running, hydrogen IC engines, which are coming. I call them emerging markets. But the bigger section is existing markets. That's Cipher Neutron's focus. If you look at the oil and gas industry, fertilizer industry, the butter that we eat every day, chemical production, mining industry, the ore reduction, all these processes, all these sectors, they use green hydrogen or hydrogen. At this stage, they're using gray hydrogen, but of course, the plan is slowly adapt or change to the green hydrogen markets. This represents billions and billions of dollars of market, and the expectations for 2030 and 2050 are into trillions of dollars of market. So again, I think for all the electrolyzers companies out there, I don't see any competition at this stage. I mean, there's enough green hydrogen to be made. So again, we need to encourage more companies and to encourage the new technologies. Existing production methods. I mean, as we know, there are mainly two ways to produce green hydrogen. I mean, if you follow news, I mean, there's new companies every day, which is a good thing, but existing markets or the existing share is between alkaline electrolyzers and the PEM electrolyzers. Alkaline electrolyzers is a traditional way to produce green hydrogen. However, it comes with lots of cons or lots of disadvantages, one being the huge footprint, low hydrogen production, low pressure of green hydrogen produced, and highly corrosive process. Then we have the PEM electrolyzers, which are now dominating the industry because of their high current density, meaning low footprint, high efficiency, and high output pressure. However, these also come with some disadvantages, which include they are made up with PGMs or proton group metals. I mean, one of the key things in the PEM electrolyzers to increase the efficiency and the performance is to use platinum, iridium, lithium, all these minerals or platinum group metals or rare earth metals. And the second thing is the use of PFAS, especially in the European countries now. PFAS is a big concern because the membrane that is used inside the PEM electrolyzers it comes from PFAS. Talking a little bit about the hydrogen, or sorry, the PGMs concern, because as we know, we're talking about trillions of dollars of market. We're talking about billions of dollars spent in the research and development of green hydrogen technologies. But the thing is, we need to do proper sustainability study. We do not even have enough iridium to justify the scale that we need, or the iridium that is required in the electrolyzers. So definitely we need platinum group free electrolyzers, and that's exactly what Cipher Neutron is doing. Not only the iridium section, but also one thing to understand is more than 90% of the PGMs, they are based in South Africa. So anytime we have things like COVID-19 or some other sanctions, it will be very hard to satisfy the green hydrogen market in those scenarios. They also have environmental impact, because then the question becomes, are we even talking about green hydrogen? Because just to make 1 megawatt PEM electrolyzers, we need anywhere from 500 grams to 2 kilograms of platinum group metals. One of the thing is, or one of the argument is, this number is okay because we can recycle it. But again, it's like a chicken and egg problem, because when we say that on one hand side, the companies, they're trying to reduce the content of iridium or platinum onto the membranes to use as a catalyst to break water. But on the other hand side, if you talk to any recyclable company or recycling company, they will tell you that if you use below a certain content of platinum group metals, it's not possible to recycle. I mean, the recyclability is almost 0% when we are trying to reduce the content of iridium or platinum. So as I said, it's a chicken and egg problem. If we use too much platinum, too much iridium, we do not have enough of these minerals in the earth. If we use too little, then we cannot recycle it. The third, or the second big point is PFAS. As I mentioned, I mean, and Europe is actually looking to ban certain PFAS. PFAS are also called forever chemicals, and they can stay in the environment for thousands and thousands of years. According to the Agency for Toxic Substances and Disease Registry, PFAS has the potential to affect growth, learning, and behavior of infants, and also in the older children. They can lower pregnancy. They can also increase the risk of cancer. So we need something which is PGM-free and PFAS-free. This is where Cipher Neutron's AEM technology comes into play. We have developed a highly efficient way to produce green hydrogen, and we do not use any PFAS or PEM, PGM-based minerals. We are the first North American company to deliver or to commercialize AEM technology. Just one point to note that we are backed up by 20 years of research and development. Our partner, Dynacert, is into research and development of alkaline electrolyzers and in generally green hydrogen economy from last 20 plus years. So we do have know-hows, and we have huge research and development backup from Dynacert also. The AEM benefits that Cipher Neutron's AEMs offer. We have developed a highly efficient system. Our efficiency levels are north of 80% based on HHP levels. If you look at the industry standard is right now is 77%. So why is it important? Higher the efficiency, meaning we can produce more green hydrogen with the same input power, meaning lower OPEX, operating cost. This aligns with what Biden administration said, and all the governments across the Europe across the world are saying to bring down the price of green hydrogen lower than $2 a kg. And the idea is, if you have higher efficiency and lower capex, you can achieve this goal. Otherwise, it's not realistic to compete with gray hydrogen. So that's why the efficiency levels of electrolyzer has to be above 80% to even discuss that we're going to challenge the prices that we see from gray hydrogen. High ampacity, meaning we can achieve or we can produce more hydrogen per centimeter square. So in our case, we have achieved 2 amps per centimeter square. Just one thing to note, that is in the alkaline or the traditional electrolyzers, the average ampacity is less than half amp per centimeter square. So we are 4 times or more hydrogen produced per unit area than traditional alkaline electrolyzers. High pressure, we have achieved up to 30 bars of high pressure or the delivery pressure of hydrogen. This is also very important to understand that basically in our case, I mean, which is true for almost all the companies, one of the big thing is hydrogen should be used directly out of the electrolyzer to the source. So saying that, I mean, for example, we have some mining customers who need 20 bars of hydrogen, and using a traditional alkaline based system, will not cut it because the pressure output from the traditional alkaline electrolyzers is close to 5 bars or maybe even maximum 10 bars. So they need to source another, additional compressors, which is additional capex for the project. So we have a compact design, no precious metal use, and a product price reduction. If you look at our prices, the AEM prices that we offer, we can, this is the selling price, by the way, for electrolyzer, less than $1,000 USD per kilowatt. And we will discuss the pricing in upcoming slides. So why we are better, why we have a superior AEM technology is because we have, so any electrolyzer, I mean, especially AEMs or PEM electrolyzers, they have main key components. There are three of them. One is flow fields, ink preparation, and the membrane. We work very closely for our membrane with Ionomer Innovations, which is pioneer in North America for developing state-of-the-art amnion or AEM electrolyzer membranes. We have a very unique way to prepare our ink. The ink that we prepare, that is coated on the membrane after that to excite the water molecules to break into hydrogen oxygen gases. We have a unique way to prepare it, and we have a unique catalyst recipe that we use that helps us to achieve that efficiency levels. And then also we have patent pending flow fields that allows us minimum pressure drop, that allows us maximum water flow, and it helps us in achieve more efficiency levels. Minimum degradation, one of the things that I think we already discussed, and I think one of the big concern for the electrolyzers out there in the field are the lifetimes. So the degradation levels, we have seen less than 0.5% degradation after 1,000 working hours. And this testing is done on 10 kilowatt stack. So is it on a decent size stack, not on a one cell or a small, 10 centimeter square cell. We have done this on an actual 10 kilowatt electrolyzer system. So if you extend that to 1 year, that will mean 4% degradation over 1 year time. We have ran our electrolyzers for more than 3,000 hours, 3,500 hours, and it's still going. I mean, we are testing them under various conditions, and we have seen minimum degradation levels. And for the European benchmark, it's 7% or 8%. We are almost half of that. So meaning our electrolyzers, we are predicting the AEM electrolyzers that we manufacture, they can last 8 to 9 years, or way more than a traditional PEM electrolyzers can last. Talking about the selling prices, we are on, if we talk about the electrolyzer prices, we know they're all over the map. I mean, if you source it from China, you source it from Germany, you source it from North America, there's a huge price difference. So what we have done is we have done extensive study to find out what would it cost for any electrolyzer out there on an average basis. And what we have seen is we are anywhere between 20 to 30% cheaper or more affordable than the traditional PEM electrolyzers in the field. Our selling price, this is our selling price for 10 kilowatt stack, which is able to produce almost 2,000 liters of hydrogen an hour, is $10,280. And this is USD prices. Our also focus is because the markets we are targeting, they need big electrolyzers. For example, 100 kilowatt system single stacks, 250 kilowatt single stacks. That's where our research and development goal is right now. And then we're developing, I would say, world's biggest AEM electrolyzers very soon. And we have just announced our collaborations with Ionomer Innovations, with Danasearch to go big into bigger stacks, I mean, or 250 kilowatt AEM stacks. Why we need that? Because as we go up, it's in everything, in steel industry and in food industry. If we have bigger systems that we can make, we get volume discounts, and we can make it at even further cheaper price. So we are targeting that 250 kilowatt stack will be close to $942 selling price. Why bigger stacks? Because as I mentioned, the industry is too big. Nobody needs 2 kilograms of hydrogen a day. Whenever we talk to our customers, for example, ammonia producers, steel manufacturing, hydrogen fueling station companies, mining industry, they need tons and tons of hydrogen a day. So our target market is big industries, and our goal is to develop 250 kilowatt stack so we can deliver, because in our mind, it does not make sense to have 10,000 electrolyzers, small electrolyzers, plumbed together to deliver, let's say, 1 ton of hydrogen a day. Our focus is to have minimum system in the field, but with a larger capacity. So just as an example, for ammonia production company, if they produce 1 ton of ammonia a day, they would need close to 200 kilograms of hydrogen a day. CN system or Cipher Neutrons will focus or will sell them to 250 kilowatt electrolyzers versus 50 times 10 kilowatt or whatever the number is. So that's why the Cipher Neutron is focused on building larger scale AEM electrolyzer stacks. Partnerships and MOUs. I mean, as I mentioned, our research, one of the big thing we have is we have on our back our research collaborator company, Dynacert Inc., which already has more than 50, which is in more than 50 countries with more than 47 dealers across the globe. So we have a huge network. We're already talking to companies across the globe. In India, one of the things I would mention is, I mean, India is going big into green hydrogen. I mean, they have mandates from the governments to go into green ammonia by 2027 or whatever the goals are. I mean, they have specific goals for specific departments, and numbers, they look huge. I mean, at this stage, I mean, even running on full capacity, there's not enough electrolyzers out there in the market to justify or to satisfy the demands that just India brings to the table. We're looking into South Africa, South America, North America, European countries. So we are a global company with footprint in more than 50 countries. So that was the AEM electrolyzers that we have, but we also in our research and development, we're working on the reversible fuel cells. So we are the first company in the world to have a reversible fuel cell coupled with graphene storage. So basically what you see on your screen is, you can call this a hydrogen battery. So what we do is we produce hydrogen during whenever we have free electricity or surplus electricity. We have a unique system and 2 separate tanks that are filled up with graphene. We pump graphene into the system or the reversible fuel cells, and we store that hydrogen into graphene. So this is world's first non-compressed hydrogen storage method. And then we pump back the same graphene or the charged graphene that we call to the system, and the system becomes a fuel cell. So this is a unique way to store hydrogen, or this can be used as a hydrogen battery. Right now, this is still in research and development phase. We have proven the concept as a much smaller level, 100 watts. And the next step for Cipher Neutron is to make it 5 kilowatt system or 10 kilowatt system, because that's what an ideal house or ideal use would be for this kind of technology we have. If you look at the use case scenarios, I mean, this is perfect for energy storage, residential and commercial power backup systems, off-grid communities, hotels, cottages across the globe, utility markets. So this is where our reversible fuel cell will be applied in the future. If you look at the focus and all these things we're discussing to reduce CapEx, to reduce OpEx, because governments across the globe, including Biden administration, the goal is to go $2 per kg by 2026, and after that, less than $1.50 of green hydrogen by 2030. So the only way to achieve this is to have almost 80% reduction in electrolyzer cost. Otherwise, as I mentioned, we shouldn't be even talking about green hydrogen coming into next few years if the electrolyzers are still at the prices that we are buying them today, especially the PEM electrolyzers. They're highly expensive. It's not just, they're not just little over, they're almost 3 or 4 times the price they should be. So an 80% price reduction is necessary. And just to as we discussed in the previous slides, we're already 30% cheaper than the existing PEM electrolyzers. The efficiency has to go up, because efficiency means lower operating cost. We have already achieved more than 80% efficiency, and again, there's always room for improvement. I mean, this is not the end. Our research and development is working day and night now to make sure that we even go higher efficiency levels, and also to increase to further increase the membrane life, or the lifetime of the electrolyzer, to go close to 100,000 hours. All these things combined will achieve us the goals that we're talking about of green hydrogen less than $1 per kg in near future. Product launch timeline: we already have 10 kilowatt electrolyzer system that we're shipping out by end of this year. We already have an assembly line, so we are working together with our partner Dinosaur Inc., which already have a semi-automated production line. So we don't have to wait another 2 or 3 years before we can set up our own production line. So all these things are already set up. We are launching 50 kilowatt AEM stacks next year. And then after that, as I mentioned, we already are working on 250 kilowatt stacks for the bigger hydrogen markets, high pressure, high volume hydrogen needs. We have several patents already filed. Our AEM electrolyzers are patent pending, and we are filing many more as we speak. Again, hydrogen right now is the best investment opportunity. Hydrogen is the future. It's a niche market, and what we have is a disruptive technology. We have no competition in reversible fuel cells. So I would say it's the best time to go into the hydrogen markets. Some of the news, I mean, as I mentioned, I mean, we just launched we kicked off our research and development to 250 kilowatt AEM electrolyzers. We signed several deals. We signed several MOUs across the globe to supply electrolyzers to mining companies, to ammonia manufacturers, to chemical industries who want to make methanol. So, I mean, every day the market is changing, and it's surprising sometimes that what they actually use hydrogen for. I mean, there's so many new products coming that use hydrogen, and including the hydrogen fuel cells, hydrogen IC engines, because all these things, or all these fuel cells, hydrogen IC engines, will make sense only if we have the hydrogen as the fuel. I mean, we cannot use gray hydrogen and try to save the world from emissions, because that doesn't help. I mean, for the hydrogen engines, for the hydrogen fuel cells to work, it is must that we have hydrogen or the green hydrogen produced by water electrolysis, and AEM is the best way to go forward right now. Thank you very much. I know we are almost 5 minutes left into the presentation, so I will open up the floor for any questions the audience has.
Yes, excellent. Thank you. We have already a few questions in the chat. So first of all, you're talking about US dollars per kilowatt. What prices per kilowatt electricity did you assume?
So see, that is the operating cost. What I mentioned was the capex, that to sell the electrolyzers, 1 kilowatt electrolyzer will cost on per kilowatt basis will be close to $1,000. The electricity is different in every region. I mean, that will be the operating cost. For example, you can find electricity even in Ontario, where we are based in. I mean, in the nighttime, the electricity could be 5 cents per kilowatt versus 15 cents. So that will be the operating cost. And that's actually, it's a good question, because that's what decides how much the green hydrogen per kilowatt is. But again, as I said, we have one of the highest efficiencies in the market. So no matter what, no matter what pricing we're paying, the green hydrogen produced from the AEM electrolyzers that we produce will be 6% cheaper than the competitors.
Okay, and maybe have you seen the presentation from Enapter, the one before you? And can you maybe talk about the differences between your technology and the one from Enapter?
So AEM is not new. AEM has been in discussion from several years, and I actually commend Enapter for being where they are right now. I mean, Enapter has a unique way also, and so does we. I mean, Enapter, as I mentioned, right now, it's the hydrogen market is so big. And even Enapter said that, I mean, I was listening to the presentation, they said, even by 2030, they're going to still import green hydrogen from other countries. So I don't see this as a competition. And I congratulate them on successfully going into the megawatt electrolyzer phases. The only difference would be they're combining 2.5 kilowatt electrolyzers together to make one big one. On our hand side, our minimum or the smallest size we have is 10 kilowatts. So our really focus is big stacks, 250 kilowatt stacks, or maybe even bigger in the future. So yeah, I mean, and that doesn't mean that they won't go this route. I mean, it's just that, we have right now different customers, different markets, and we are happy that there are other players also in the market for the AEMs.
Good. And do you produce the PM yourself, or and also how do you see the competition from Chinese players?
So we are not PEM manufacturer. We are AEM. I think maybe what you meant was the CCM, or the catalyst coated membrane. So we outsource the membranes, but everything else is in-house. So we design, we have our own ink preparation techniques, machines, everything, A to Z, we have everything in-house. The Chinese players at this stage, I think I mean, of course, when it comes to, steel and, all these raw materials, China is a place where things are much cheaper. But I would say in the scenario that I mentioned, we are very competitive even today with Chinese player out there. And the other thing is there's not many AEM electrolyzer manufacturers in China. They rely on PEM electrolyzers, which use precious metals, highly expensive platinum, iridium. So that's why we are pretty competitive with Chinese electrolyzer manufacturers. Another thing would be, again, as I said, I mean, it's a new economy, and we do not say that we have grudges with the different countries and stuff. We, at the end of the day, I mean, if we have strategic joint collaborations, we would definitely love to explore how we can outsource few things, but the goal is right now everything made in Canada, and bring Canada to the world map, to own a technology or to have a technology by Canadian company that is made and manufactured in Canada.
Excellent. Maybe one last question. Do you already have actual electrolyzers up and running at client sites, or is it still all in research and development?
So I won't say it's a research and development stage. We have a commercial product. The deliveries, as I mentioned, and we are modifying the existing alkaline manufacturing facility, and they will be in the field by December this year. However, we do have several clients, I would say, that have done already the pilot project testing and several other testing. So some of them, they're running from last 1.5 years, and even in the labs is running from last 2 years. But as a final product in the market, we will be shipping out the approximate shipping date right now is for our 10 kilowatt system is December 2023.
Yeah, looking at the time, we are already the time's already up. So thank you very much.
Thank you very much.